We'll be discussing now categories of occupational health hazards. There are different categories of occupational health hazard that you need to get familiar with. And categories are chemical, physical, biological, and ergonomic. If you look at this kind of energy wheel, and it also has some of these categories inside, okay, like motion, gravity, mechanical, electrical. There are so many, like temperature, okay, equipment wise, radiation wise, sound. So first for the chemical, okay, there could be dust or fiber kind of occupational health hazard, fumes, smokes, mist or aerosols, gases, vapors. On physical side, you have noise, temperature, illumination, vibration, pressure, radiation available. On biological side, you have bacteria, virus, fungus, mold, mites, insect, parasite, plants, and animal. And ergonomic side, you have the repetitive motion, heavy lifting, occurred of static posture, fatigue, overexertion, monotony, perceptual confusion or overload, varying metabolic cycle, direct pressure, excessive force, like that. Chemical on dust or fiber, here are a few examples like solid particle of material such as silica, coal, cotton, asbestos, and fumes like particle formed when material from a volatilized solid condensed in cool air such as nickel, beryllium, zinc, iron. Smoke, here are a few examples like solid liquid particles resulting from incomplete combustion of materials such as wood, coal, plants, petroleum products, and mist or aerosol side, you have liquid particles suspended in air such as chrome and hypochlorite acid, sulfuric acid. Gases side, you have formless fluid that expand to occupy the space or enclosure to which they are confined, such as hydrogen sulfide, chlorine, carbon monoxide, and vapor side, the gaseous form of normally solid or liquid substances subject to evaporation, such as gasoline, alcohol, paint thinner, solvent. Physical side, you have noise, unwanted or excessive sound, whereas temperature side, you have high or low extremes. And illumination, illuminating level, intensity and glare. Vibration, to and fro, motion or oscillation, transmitted to the body as whole body vibration or segmental vibration. Pressure side, inadequate or excessive atmospheric force for the body. And radiation side, the process in which energy in the form of rays, light, heat, etc. is sent through space from atom and molecule as they undergo internal change. Ionizing radiation evolve from the nucleus of an atom. Non-ionizing from varying electric and magnetic fields such as ultraviolet, laser, infrared, microwave, radio frequency. Let's look at the biology here because this chapter is based on noise and hearing conservation program. And you are looking at a ear, okay, and it's a cross section, and you are seeing the outside of the ear, and you have a tunnel here, and there is a eardrum here, and there are three different bones, very soft and small bone, we call MIS, Malleus, incus, and stapes, and it is attached with a snail kind of structure here, and it is filled with fluid, and it has nerve attached, okay, so this is attached with the brain. So what happens when sound comes here, it goes through the tunnel, it vibrates this membrane, and with the vibration of the membrane, these three bones also, they vibrate, and it vibrates the fluid inside, and this vibration of the fluid, it actually gives information to the sensors here that goes to the brain, and we get the information what is the sound what kind of sound, loud, soft, and all kind of things. It is also showing here a skin where it is showing here that cross section of a skin where it is showing that different layers of skin, epidermis, dermis, and where the top part of the skin, very thin part of that, and earlobes is coming from it. There is sweet glands, and it has this kind of blood vessels also connected, and the nerves also, nerve and blood vessel coming through it. This is showing here lungs. So basically, if we inhale in here, basically it goes through it. It has a lot of porous, with alveoli. It is going there, and ultimately we get the oxygen. So it attaches with the blood cells. So we get the oxygen through it. So it is showing here the cross section of that tiny part, alveoli, and all kind of things. So when you have any kind of lung disease, pneumonia, and all kind of things, it is totally filled with liquid, and we cannot get any oxygen. And this is showing here for a radiation. When radiation goes and it cut the DNA, ultimately you have a bad cell, and bad cell create thousands and millions of bad cells, and that create a tumor, and tumor basically it's a bad tumor, and that is basically cancer.